This lesson is in Unit 3 and it is on chemical bonds. If you know very much about the Beatles, you know they had a song called Come Together, and that's what atoms and elements do when they bond chemically. So that's why that is present. The first thing we have to talk about when we're talking about bonding is electronegativity. Just put it in layman's terms, electronegativity is how attractive an atom is. Now, if you look at the periodic table, you'll see that all of the elements in group 17 or 7, the halogens, are super attractive. And the reason why that is so is because they have 7 valence electrons and they only need 1 valence electron to be complete. So these elements, all of them in group 17, are the most attractive elements on the periodic table. The most attractive element of all is fluorine. Fluorine is at the top of group 17 or 7 at the halogens, and it is a very super attractive atom. If you are looking at the periodic table, you can see that fluorine is up here in this group, and it is the most attractive. That's the main thing that you need to remember. If you remember that fluorine is the most attractive element on the periodic table because it only needs 1 valence to be complete, then you wouldn't have any problems when it comes to electronegativity questions. Now, as you move across each period, the atoms become more attractive. And the reason why that is because all of your nonmetals are over here together and they gain electrons. And they don't have to gain many electrons to be full. For example, oxygen only needs, it's in group 16 or 6, and it only needs 2 electrons to be complete. It's not as attractive as fluorine because fluorine only needs 1. If you come all the way over here in group 1, francium is the least attractive element of all the elements on the periodic table because it has that 1 valence electron that it's trying to get rid of, and it's difficult for it to do because it's so big and it's just not attractive. So least attractive element is francium. Most attractive element is fluorine. And again, that is because fluorine only needs 1 valence electron to be complete. And it has a lot of high energy, and so it is easy for it to get that electron. Now, there are 3 types of bonds, and hopefully we're in class today and you have a foldable. But in case we're not, there are 3 ways that atoms bond to create new substances. The first type of bond is an ionic bond. Now, an ionic bond, let's go back and look at these dots again because we know that when they are touching, there is a bond. And you can tell that this is 2 different atoms because they're different colors. What you need to know about ionic bonds is that it's always a metal bonding with a nonmetal. And the reason why that's so is because metals lose electrons and nonmetals gain electrons. And so when you have an ionic bond, there is an actual... There goes my puppies again. So when you have a metal that gives away an electron to a nonmetal, that is when an ionic bond occurs. In a covalent bond, there is no transfer of electrons. These atoms are sharing electrons. An important thing to note here is that you have 2 nonmetals. There's no transfer. They are sharing an electron. In a metallic bond, you've got 2 metals sharing an electron. So in an ionic bond, you actually have a transfer from the metal to the nonmetal. In covalent bonds, you've got 2 nonmetals sharing an electron. And in a metallic bond, you've got metals sharing electrons. So let's look a little bit closer at ionic bonding. When I say a transfer of electrons, I want you to understand what I mean. So here is sodium, and sodium is a metal. It is in group 1, and we all know that if it's in group 1, it has one valence electron that it needs to get rid of. Chlorine, on the other hand, is a nonmetal. And if you look at chlorine, it's in group 7, and so it has 7 valence electrons, and it only needs one to be complete. So when sodium and chlorine bump into each other, sodium is going to give, it's a metal, and it is going to give that one valence electron to that chlorine. Now, when that happens, you now have that outer energy level for sodium is gone. And so now you have sodium with a complete full and outer shell of 8 valence electrons. And because chlorine gained that one electron that it needed to be complete, it also has 8 valence electrons in its outermost energy level. So the thing to remember about ionic bonding, metals always give away electrons, and you can tell how many they're going to give away due to what group number they're in. If they're in group 1, they have 1 valence electron, they're going to give away 1 electron. If they're in group 2, they have 2 valence electrons, they're going to give away 2 electrons. If they're in group 3 or 13, they have 3 valence electrons, and they're going to give away 3 valence electrons. If you are a nonmetal, you are missing electrons to be complete. So if you're a nonmetal, you're going to take electrons from the metal. So if you're in group 16, for example, you have 6 valence electrons, so you're going to take 2 from a metal to make yourself complete. If you're in group 17, you only need 1 valence electron to be complete, so you're going to take that electron from a metal. And that is how ionic bonds occur. It is the transfer of electrons from a metal, also known as a cation, to a nonmetal, also known as an anion. In covalent bonds, there is no transfer. It is 2 metals, and so what they do is they share 1 pair of electrons. So I can tell which element this is by counting how many valence there are before they share. So we've got 1, 2, 3, 4, 5, 6, 7. So this is an atom that is in group 17, and so is this one. So when they join together and they share an electron, now they each have 1, 2, 3, 4, 5, 6, 7, 8. In a metallic bond, it's basically a combination of the two. Metallic bonds occur between metals. You know, the word metallic sort of gives that one away. And so they form what is called a sea of electrons. And the reason why that happens is this is the nucleus of one metal, and this is the nucleus of a metal. So instead of a transfer from one to the other, like there is in ionic, or getting close in sharing, like there is in covalent, they share all of their electrons. So these 3 electrons right here around this nucleus, they're not loyal to that nucleus. They are going to share electrons just randomly with all the nucleus that are involved in this metallic bond. So in this situation, you have your nucleus surrounded by electrons from all of these atoms that are bonded together. Now, when you apply electricity, these things will move very freely, and you can make a current. They're metals, and that's what they do. Now, let's talk a little bit more about electronegativity values. So if you've got 2 atoms, and they are both very similar. In other words, you know, they're either both very attractive or they're both very unattractive. Okay, so the atoms would then be classified as either metals in a metallic bond or non-metals. So you have a metal and the metals bonding together, or non-metals in a covalent bond if their values are very similar. For example, all of the elements in group 17 have about the same electronegativity value. They're all super attractive because they only need one valence electron. And so if you're looking at nonmetals in a covalent bond, if they are, say, fluorine and chlorine, so they have very similar types of electronegativity, then you're looking at a nonpolar covalent, and we'll talk more about that in a minute. But if it's two nonmetals and their electronegativity values are very different, for example, fluorine is a lot more attractive than oxygen, then it would be a polar covalent, my bad. All right, now let's go back. If you're looking at two atoms and their electronegativity values are very different, in other words, one of them is very attractive, like a nonmetal, and the other is very unattractive, like a metal, then you are going to have an ionic bond. So if their values are very different, you're looking at an ionic bond. If they're very similar, you're looking at either a metallic bond or a covalent bond. Okay, so again, an ionic bond is when you have a metal and a non-metal, a cation and an anion, and they form a bond when one transfers an electron, the metal transfers an electron to the non-metal. Okay, and we've already talked about cations and anions. So just as a reminder, a cation is positively charged because it is going to give away electrons, and all metals are cations. Anions are nonmetals. They have a negative charge because they are going to gain electrons. Ionic bonds always result in a crystal structure like salt or sugar, and that's how you know it's ionic. Why do atoms become ions? We already know this. They become ions, they bond so that they can have a full octet or a full 8 in their outer energy level. So they want those 8 valence electrons. Noble gases don't bond because they already have those 8. But if you have a metal and a nonmetal, there's going to be an exchange or transfer of electrons so that they can get that full outer shell. Okay. So sodium has 1 valence, chlorine has 7. And so when they bond, sodium gives that 1 to chlorine. And now you have NaCl. Again, how many valence electrons? We're going to skip this part because that's S&P, and that is very much chemistry. So we're going to stop here for just a minute. I want you to look at these and determine, for example, how many electrons potassium is going to give to fluorine. And all you have to do is look at the periodic table to see what group they're in, and it'll let you know how many electrons are going to be transferred from the metal. And the metals are always written first. If you look at these, they are all metals, to the nonmetal. So take a minute and look at that. So again, here is the periodic table with the charges written across the top. Group 1 is +1. It is going to lose 1 valence electron. Group 2 is +2. It is going to lose 2. Group 3 is +3. It is going to lose 3. Group 4, if it's a metal, it's going to lose 4. If it's a non-metal, it is going to gain 4. And then all of the gases over here on this side are going to, group 15, for example, is going to gain 3, making it a -3. Group 16 is going to gain 2, making it a -2. Group 17 is going to gain 1, making it a -1. And group 18 will not bond. That's your noble gases.